please welcome the former diplomat and current international advisor on planetary change, Alexander Verbeek. Thank you very much.
Thank you so much, Jeff. So weird to see myself in this enormous size on these posters. These days have been absolutely amazing in meeting so many of you and hearing all your inspiring stories. And that's the difference from a lot of other conferences where I go. I work a lot on climate change and environment, and there the mood is often quite negative, especially if you now read the newspapers about what happens in politics and what happens on the planet. And then being here and hearing all these stories about creativity and innovation and coming with new solutions, and then people in completely different businesses helping each other, giving each other advice on how to do things better. That is really inspiring. So don't go to the kind of conferences I normally go to, but I'm gonna scare you with a few numbers because then you know a little bit of where I come from. And so let's start there, because you are giving hope to the planet with your solutions, and the planet needs it, because every second more than 300 kilograms of plastic is entering the ocean. And every minute, 10 football fields of tropical forest are lost. And every hour, 3 species of plants or animals are going extinct. And every day, we emit 114 million tons of carbon dioxide into the atmosphere. And I know that you're now dying to know whether that is more or less than you need to fill the Empire State Building, because that's something I needed to measure to imagine how much that is. So I calculated that for you. It's actually 63,000 Empire State Buildings that we fill with CO2 and release that in the atmosphere, and tomorrow we do the very same thing again. So those are the kind of challenges that we are facing. Our disregard for the environmental boundaries of this limited small planet where we live with 8 billion people is staggering. On the very first slide, I'll show you, this is 35 biodiversity hotspots as defined by Conservation International. And all of these are heavily threatened by habitat destruction and by human activities. So for instance, global wildlife populations in the past 50 years, so basically in our lifetime, have plunged with more than 70%. And if you look specifically at Latin America and the Caribbean, it's 95%. And these are not just, statistics to mention in a conference. This is just the unraveling of these wonderful biodiversity, these wonderful ecosystems that needed millions of years to evolve. And we just need one lifetime to destroy all of that. And I spoke about climate change, and I spoke about pollution, or about biodiversity, but about pollution, not sure if you can see what's in these brains here, but in each and every one of us, on average, we have now about 10 grams of microplastics in our brains, which is equal to 2 credit cards. And that is 1 credit card more than only 8 years ago. And scientists don't know what these microplastics will do with our brain, but it doesn't sound like something that makes me at least very enthusiastic that I have that in my brains. So what I want to tell you about today is numbers that really give hope, because we have those numbers too. But before we go there, and before I will show you numbers that show how human innovation, empowered by analytics, is helping us to fight back against environmental destruction, I want to keep you a little bit in this environmental sphere. What you see here is, you see the months of the year at the bottom. This is all the years from 1940. You see the Earth getting warmer. The 0-degree line at the bottom, that's basically pre-industrial atmospheric temperatures, like it was before the Industrial Revolution. In 1940, we were a little bit above it. You see these lines going up. Why I'm showing this one is because the top one, from summer 2023 to summer 2024, is so much higher above all the other ones. These are numbers that really shock climate scientists, and they are used to shocking numbers. So it was the first time in 2023 that 2024 that we breached this 1.5 degrees, this famous 1.5 degrees Celsius threshold. So 2023 wasn't just breaking records, it was just shattering the records. 2024 was worse. And if we look at the past 20 months, and these are numbers that came out yesterday, including February, the past 20 months, 19 of them were above the 1.5 degrees of warming. So this is one that came out last night actually by Copernicus, let's say the European NOAA. What you see here is this line is the 1.5 degrees line. So July was a lucky month. That's the only one that is below there. And you see where are we in the summer 2023, in June? You see that suddenly there's this rise, which was predicted by James Hansen, who is, you may remember him as the young scientist in the 1980s that in the American Senate testified about climate change, and all his predictions were absolutely correct, based on very limited data, by the way. And he predicted about 2 years ago that we were going to see this kind of spike. It's happening now. Here you see what's called the climate spiral made by NASA. The green circle is 0 degrees, so that's let's say how the climate was supposed to be. You see that for a long time, let's say until the 1940s, we were more or less there. And then it slowly started to grow. Look at about 1990, what happens there. So this is all, you know, like we're now really in our lifetimes, at least I am. See what happens. It's really spiraling out of control. It's now out of this 1 degree boundary. And this 3D image really shows you how it is expanding. And actually, if you would really update it now, it would even be a little bit wider. So climate change is no longer abstract. I've been talking about climate change like forever. I remember giving talks that there was only 0.6 degree warming, whereas now we talk about 1.5, right? So long I've been around, or so quickly climate is changing. 2 examples. Somalia, poor country, East Africa. After prolonged and extreme drought, massive floodings followed. It really destroyed the agricultural economy. Millions of people have been displaced within Somalia. Hundreds of thousands have moved to Kenya. And more than 4 million people are now at the risk of hunger and starvation starting next month. I'm mentioning this because likely none of you have heard about this. This is not in the news, but just Google it, you can check these data. To contrast that, recently we had another news fact that none of you will have missed. That is the wildfires in California. It had 24/7 coverage on social media, on CNN, or wherever you get your news from. And we had some of the richest people in one of the richest countries in the world that had to flee for their lives for apocalyptic scenes that they normally film next door in Hollywood blockbusters. So you might think that climate change is some kind of equalizer. We will all be hit by climate change. That is right, but it doesn't make us more equal. Actually, the opposite is true. What you will see is that climate change will exacerbate the differences between the rich people in the world and the poor people, within countries and between countries. And since we live at a very worrying time where tensions between countries are rapidly rising, that is something that we should keep in mind, and that makes things things worse. So all these environmental challenges, biodiversity loss, pollution, especially climate change, are very much about who is willing to sacrifice what for other people. It's about sharing. We have only one planet, there's only 8 billion people, and we somehow have to live together in this space. So it's about trust, it's about cooperation. It's the tragedy of the commons, but then on a global scale. So in short, it is about political will. And unfortunately, political will for climate action is rapidly declining, especially in the last few months, even though all the alarm bells are going off, as you saw in that climate spiral. And nature has this unpleasant characteristic that it doesn't wait for our political consensus with the consequences. So this may seem like a very strange moment to talk about hope, but that's exactly why we're here today. Because with every 1/10 of a degree less global warming, we do make a difference. A 1.9 degree warmer world is horrible, but it's still vastly better than a 2 degree world. So we need all hands on deck. And nothing is more motivating than to focus on stories that offer real hope. And there's a common theme in all of these stories, and that is the unprecedented power of human innovation, often supported by analytics and smart experimental design. And innovation is critical for both the mitigation, so avoiding that we get more climate change, as well as for the adaptation, that we adapt to what climate change is causing. So just to illustrate, a few examples from my home country. I guess by now all of you will have worked out my accent that I'm a Dutchman. So that's that small country by the North Sea that is mostly below sea level. At least most of the people live below sea level. So we're threatened from all sides. There's rising sea levels. Sea gets warmer, it expands, and the ice sheets are melting, so the sea level rises. Fiercer storms, so together the surge, the storm and the rising waters is higher. And then from the other side, we are the delta of some of the biggest rivers of Europe. And so we have floodings of rivers as well. So what did we do? Just a few examples of creative solutions. We created a room for the river. After in the 1990s, we had enormous floodings by the rivers. We deepened the rivers, we widened the rivers, or at least we created a room that when we need a lot of water to get through, that there's enough water. So we replaced dikes, we created all kinds of new levees and canals, and it's an intricate work. I could talk about it for a long time. It's a $2 billion project. And another one I want to show is this one. This is basically 2 Eiffel Towers that you put on the ground, and then you can close the gates to the North Sea. So this is close to Rotterdam. That water is 360 meters wide, and it's a barrier. So when there's a surge from the sea, you can close. And this is the last one I want to mention. This is a bit southwest of The Hague, and this is an example of building with nature. So what we used to do was every 4 years, all along the coast, we put up a lot of sand to widen the beach and to strengthen the dunes to keep the water out. What we then decided to do, a creative engineer came with an alternative approach. He said, instead of every 4 years doing all that work, we just once in 20 years take one spot where we put 20 million cubic meters of sand, and that's it. We just leave it. Then nature, with the currents and the winds and the waves, is spreading that sand along the coast. And it's far cheaper. We have to do it only once in 20 years. It enhances biodiversity. It creates more space for nature as well. Whereas those every 4 years activities that we used to do were pretty bad for the environment. So this is a building with nature example. So what connects all these examples is the power of innovative new approaches combined with the political will to actually do it. So a few years ago, when there was floodings in Germany and Switzerland and Belgium and Many people died, billions of euros of damage. All that water came through our little low-lying country, and we had no problem at all. So adaptation works. Now, adaptation is part of the climate action that we need to take. The most important one is, of course, to avoid that we get more climate change. So rapidly reducing emissions and working more more sustainable. So today I want to focus on the remarkable power of innovation and analytics to drive positive change on multiple fronts. Let me take you back to December 2015. I remember an evening in Paris. We're sitting in a typical Parisian cafe with these round tables and far too crowded and other complaints you can have about those cafes. But it's great if you sit there with your friends and your colleagues with whom you've been at what is known as COP21. So that's that climate meeting where all countries in the world agreed that there will be we set a limit to the warming of this planet. That's the 1.5 degrees Celsius, or at least to stay well below 2 degrees Celsius. And we celebrated that, and we were discussing, is this going to work? And will we knew it was going to be difficult. And we also spoke very positively about that other famous treaty, the Sustainable Development Goals, those 17 goals and under 69 targets that basically set an agenda between 2015 and 2030 on food security, on water, on all kinds of environmental aspects, on biodiversity. Climate change is number 13 is in there. All the good things we need to do for this planet to make this a very livable, sustainable place. We were optimistic, slightly critical, and now, 10 years later, looking back, I think we can only conclude that the challenge is far worse, far more daunting than we had ever imagined. But at the same time, there's also a lot of positive stories. So let's stay in Paris for a moment, where in last summer, there were the Olympic Games, and they had to swim in the River Seine. That was far too dirty. So they had an enormous program to clean the river. As an example of a success, by now, there's 10 times more species of fish and mussels in the Seine River than there was in the 1960s. And also, probably many of you have been in Paris. I don't know if you've been there in the past few years. This is what Paris looks like nowadays. No more all that exhaust engine and all the cars and the horrible behavior of the way the people were driving there, because now they behave like Dutchmen. The whole city is just, filled with bicycles. There's hardly any cars anymore. And it is just so much improved. They've invested enormous in greenery. There's less heat islands. The air is cleaner. The river is cleaner, as I said. They have a target to be carbon neutral by 2050. And when we talk about examples of sustainable cities, we're now in Berlin, which is a very green city. By origin, it was already greener. It had more parks and so. But Berlin has made enormous progress on circular economy. There's far less waste. In 2005, only 10% of energy was renewable. By now, it's more than half. And by 2030, it should be at about 80%. And a part of that is, of course, connected, and some people might recognize this place. Some of that maybe is certainly connected to the solar energy revolution. So solar costs have fallen by about 80 to 90% every decade since the 1960s. First of all, due to technological innovation, and in more recent times also because now we can scale, and it's the economies of scale that make a difference. So if you look at the year 2023, that's the last year that I could find these data, 2 years ago, 81% of the newly commissioned energy projects in the world where as renewable energy projects, they were cheaper than the fossil fuel alternatives. So you don't even need anymore some kind of green mind of making the world better. It's just purely financially, the better option is in more than 80% of the cases to work with renewable energy. In that same year, solar energy dropped by 12% just in 1 year. So these examples of urban transformation and renewable energy are really encouraging. But yeah, sometimes we also need to look at specific places. I'm a geographer by background, and I used to live until last summer in Canada, where in New Brunswick there's a river called the Salmon River. So they started to count how many salmon are actually there. And after a year of counting, they found 31 of them. Now I moved to Norway, where we have the salmon rivers, where the wild salmon population has completely plunged. It's practically gone. Or another bad one is Cape Cod, named, of course, after cod, right? The cod is just virtually gone there anymore. So if we stay at Cape Cod, we go a little bit north to Canada again, to Newfoundland. There was a fisherman, it's this guy, he's called Brent Smith, fascinating, innovative, creative person. He was a fisherman since the age of 14. And then when the cod population completely collapsed in the early 1990s and 30,000 fishermen lost their job, he came with the creative idea to do oyster farming. But once he had started that 15 years ago, you may remember the hurricanes Irene and especially now I've got the name, the hurricane that destroyed New York, Sandy, Hurricane Sandy. You still remember when the metro was flooding, etc. This Hurricane Sandy completely destroyed the oyster farming that he had started. He had to start again. So the first time fishing collapsed, caused by humans, then climate change caused by humans, came with this extreme. So he then thought, I need something completely differently. He started all the way from scratch. What can I do as a kind of new model? And he said, I'm going to do ocean farming. So he created a simple three-dimensional lattice of ropes and baskets that he suspended in the ocean. And he created a polyculture system that grows all kinds of different species at different depths. So seaweed and shellfish thriving together in a way that benefits marine ecosystems. And what makes this so powerful is the multiple benefits. So the farms require no inputs. You don't have to water what you're growing there. You don't need fertilizer. You don't need to feed it. Instead, actually, talk about fertilizer, what they do is they absorb the excess nitrogen and phosphorus, that's the offlow from agricultural activities that would normally create these algae death zones that basically take all the oxygen away in the ocean. So it's actually very good for the environment what he is doing. These vertical structures are mimicking natural ocean reefs. They create habitats that boost biodiversity. And then the economics are very impressive. You only need like $20,000, maybe $50,000 to start this. You need, of course, a bit of piece of the ocean where you can do this farming. And with that small investment, you can create 60,000 kilograms of kelp and 250,000 shellfish every year. So what began as just one creative guy reinventing himself and his business all the time in a sustainable way is now a movement. It's called the Green Wave. They're training thousands of people from all over the planet, often people that have lost access to the fishing that they used to do, like he himself had experienced, or people that lost their job because of climate change, or by indigenous coastal communities to help them. And the oceans take over 70% of our planet. We all learned at school, but what we probably didn't learn is they provide only 2% of our food. So imagine the possibilities if you creatively develop new sustainable ways of regenerative farming. And basically you turn the ocean from a victim to a solution. And the crucial point of his story is that transformative innovation often comes from the people that are directly impacted by a problem. And around the world you see innovators developing solutions at an unprecedented pace. Imagine cities, for instance, where buildings grow their own food, where you have vertical farming, you have solar panels on top, you have LED lighting, you have hydroponics where you can grow crops with 95% less water than traditional farming. Or picture our oceans cleaning themselves. In Australia, they developed the Sea Bin project. Those are floating containers that automatically collect debris and oil spills, etc. They don't collect the fish, I checked that. And that reduces marine pollution. Or this one, this was for an engineer a very inspiring picture, a dragonfly. I love dragonflies, by the way. If you follow my account, which I will publish in the end, you'll see there's a lot of dragonflies. They're so beautiful, especially when they wash their eyes. So this inspired flexi wings to mimic the flexible structure of insect wings. And using that in wind energy, they increased the efficiency of energy production with 35%, just by mimicking nature. Other examples, materials that heal themselves. Engineers have now developed innovative materials with self-repairing capabilities that extend product lifespans. They reduce waste. And in our oceans, we can now tap into the temperature differences between the warm surface and the cold temperatures much lower through ocean thermal energy conversion. And these are not just, creative ideas or people still working on it on a drawing table. These are proven concepts that are actually already used. It's a question of scaling it. And this is where the analysis and intentional design become crucial, because behind many of these innovations is a revolution in how we use data to design better solutions, really from the start, when we start something new. And that brings me to this guy. You might recognize the picture. Anybody knows him? Very good, Fosbury Flop. So what did the guy do? This is 1968 in Mexico. The high jump was just a kind of straddle that you made. And the way we probably learned it when we were like, 10 years old at school. And he thought about it really from the start. Let's just reimagine how you jump over a high bar. And he said, I'll go ahead first. And people laughed about it, made fun about his strange technique. And then he won gold. He set a new world record. And since then, everybody has taken this revolutionary step that he took, and we do everything a completely different way. So reimagining, it's such a beautiful example, because for at least 100 years, if not a couple of thousand years, everybody had been jumping the very same way. Brent Smith, the fisherman, he did something similar with ocean farming. So instead of trying to make fishing more sustainable, which I would have applauded for anybody who tries to make fishing more sustainable, he just really started from the beginning and just looked at our whole relationship with the ocean and creating those vertical gardens. And with chemistry, we see something similar. The experts call it green chemistry. And the concept's really powerful in its simplicity. And it looks at these kind of examples, because instead of cleaning up environmental problems once we have created them, we really prevent them from happening in the first place. A couple of years ago, I interviewed Grace Lasker at the University of Washington. And we spoke about green chemistry. And she explained the importance of really being intentional from the start. If you engineer a new material, or you want to design a new cosmetic product, or designing new pharmaceuticals, you have to apply analytics early in the design process. And we can explore possibilities and anticipate consequences before they are happening, before even anything is created. And so a concrete example is Pfizer, for instance, who had to produce sertraline, which is an important medication. And they completely redesigned this process using green chemistry principles and supported by analytics. And using statistical modeling, they reimagined the entire production process from the ground up. And it resulted in improved raw material efficiency and dramatic reductions in waste and in the hazardous solvents that they use. So their commitment of Pfizer to green chemistry, that shows that environmental stewardship can easily align with, well, scientific innovation, but also, for instance, improved worker safety or cost efficiency and the quality of your product. And at the same University of Washington, in about the same time, a couple of years ago, I had a long talk with Rick Morgan, and he demonstrated how advanced analytics enable green chemistry. So he uses JMP interactive profilers to adjust chemical compositions in real time. So this makes it possible for him to immediately see how changes affect outcomes from, let's say, toxicity to environmental impact or the cost. And with these tools, chemists can design safer and more sustainable processes even before they set foot in the lab and start to work. So this is a bit like preventative medicine for the planet. So where healthcare is now shifting to preventing getting sick, so whatever, go running and eat less of the wonderful food that we had here and other advice, it says just live healthy, and then we don't have to treat you afterwards for anything that goes wrong. And this principle extends far beyond the example of traditional chemistry. Think about food production, where you can design safer processing methods, or biomaterials, where you can create material that mimics plastics and is much better for the environment. Or think about energy storage, where battery designers can now focus on sustainable materials, or manufacturing processes where you can prevent creating waste from the start instead of cleaning up afterwards, or environmental monitoring to avoid contaminants in food and medicines. And the list is endless. And companies across industries are embracing this approach. And I found a beautiful example in the well-known cosmetics producer of L'Oreal, who was the first major player in cosmetics to integrate green chemistry in their innovation model. So they've built an approach built on three key pillars. So first of all, in the choice of their materials. So they focus on primarily botanical products and raw materials. And then in the process itself, they focus on a more eco-friendly process, using less energy and use less solvents, for instance. And then finally, when they have the product, they use eco-design. So to create ingredients with much higher biodegradability. And they also have a reduced water footprint. And by the way, the company is doing all kinds of other things. So for instance, if you look at the materials that L'Oreal uses for packaging, they're always like refillable or recyclable, and it's a really green company. And they use analytics to drive this transformation. So L'Oreal has developed specific indicators to track green chemistry progress, measuring the atom economy, the waste per kilogram of product that they create, the renewable carbon content, or for instance, environmental risk of the compounds that they use. So their progress is remarkable. So by 2030, we're nearly there. 95% of their ingredients will be either bio-based, or they'll be derived from abundantly available minerals or products from circular processes. Now, this analytical approach led to breakthrough processes that would never have been possible with traditional chemistry. So using green chemistry principles, the chemists of L'Oréal developed, for instance, an anti-aging ingredient that was obtained from sawdust-derived sugar. So by combining green chemistry principles with advanced analytics, we're not just making chemistry less bad, because chemistry can have this kind of negative connotation to it. We're just redesigning it to make it inherently good from the start. That brings me to another example, which is synthetic biology. It's another revolutionary area where analytics is driving sustainable solutions. So what it's all about in one line is that you recruit living cells as a kind of microscopic mini factory that produces medicines or materials or food ingredients or biofuels. So synthetic biology replaces often all kinds of very harmful processes for the environment. A good example is the team of Christina Smolke at Stanford University. They've engineered baker's yeast to produce complex medicines that are derived from plants. So for instance, they produce opioids that traditionally require poppy farming, which is not very popular for all kinds of other reasons. And this approach not only reduces the land use, but it also ensures that you have a very consistent supply of material. You're not dependent on climate and weather disruptions, for instance. So synthetic biology benefits enormously from advanced analytics, because when you design these kind of little cellular factories, you need to understand all kinds of very complex metabolic pathways. And you also need to be able to track gene interactions. And they also need to optimize for production efficiency. And these are all areas where data analytics can really play a crucial supporting role. So a company like Antia Bio is using these techniques to address critical medicine shortages. So what they found was that climate change was threatening certain plant species. Remember, 2 or 3 species every hour that are lost. As a company, they noticed that, and their traditional supply chain that they needed for their medication, they were at risk. So with synthetic chemistry, they could produce identical molecules without the risk of the vulnerability by weather or climate change for their plants. So synthetic biology means a profound shift of everything we know of traditional manufacturing. So instead of extracting resources from nature or synthesizing chemicals in some kind of very energy intensive and wasteful process, we're programming biology itself to create what we need in the most efficient way possible. So you may remember this example of the sand engine, you know, the pile of sand that I mentioned early on, to build those coastal defenses against the sea by using natural forces. Synthetic biology is equally a very innovative and very sustainable way of building with nature. And behind every successful application is a foundation of data analysis that allows scientists to navigate this extreme complexity of working with living systems. So central to this transformation in chemistry, many of the innovations that I've described is a revolutionary change in the methodology that most of you are, practically all of you, are already aware with, which is design of experiments, or DOE. And that impact on sustainability, my focus of today, is really profound. So for centuries, scientists have been taught, and I've been taught at high school, probably all of you, that if you do a fair experiment, you need to hold all the variables stable, and you change only one. So let's say whatever you have temperature and pressure and cost or something. You only take a lot of measurements with a different temperature while you keep the rest constant, etc., etc. The BBC Science Education website is still explaining that this is the way that you have to do an experiment. And one of the problems is, of course, it's tremendously wasteful. Let's have a look at this video. And I'm not giving away any secrets for all of you. I guess all of you understand this, of course. What are we doing there? pH. So there's the acidity level. You find what's the best temperature, and then on that temperature, you do the other test. This is the way I think many of us learned this at high school. Whereas if you do it with design of experiments, you just carefully take some well-designed experiments across the complete design field, and you end up, I think here we end up top left in an area that you would never have checked earlier. So it's wasteful, but much more importantly, you come to outcomes and combinations that you otherwise would never have tried. So if you are already advocating the radical differently approach of DOE, thank you for that, because the world really needs to know much more about this. So where you allow strategically testing multiple variables simultaneously, and that you just allow the sampling and the design space much more intelligently than it was done before. So the results of DOE are dramatic. It's faster innovation, there's less waste, there's just better outcomes. For instance, sustainability. Research institution like in China, the National Institute for Clean and Low Carbon Energy, they use DOE to cut the R&D cycle times by 50%. So that dramatically improved the innovation efficiency in their clean energy technology. And what troubles me so much, especially now that I show an example all the way from China, is how many researchers and engineers and chemists still don't know about this approach, or much worse, they know about it, but they don't use it. So just imagine all those wasted resources, the delayed breakthroughs, the missed opportunities for sustainable innovation happening right now in laboratories and manufacturing worldwide, especially keeping in mind the beginning of my talk, which is all about the urgency that we start behaving differently with our environment. And it's not just only about efficiency, it's about our collective capacity to solve problems at the pace required by these environmental challenges. So it's about the upside, it's about being more effective. And DOE can just dramatically accelerate our progress for developing life-saving medications, for instance, or designing more sustainable materials and optimizing renewable energy technologies. And all of these things are so essential that we speed it up and that we do it better because there's a huge need for that. We don't have the luxury of time, and that makes work of an organization like Beyond Benign so important. And I just want to briefly mention them because they develop educational resources to promote green chemistry and sustainable science. So for instance, by providing teachers with the skills and the tools to teach green chemistry. So let me show you how this looks in practice with a few powerful examples. So Velocigrow, for instance, they approached the challenge of developing sustainable growing media for vertical farming. So the traditional methods would have required years of trials and error, but instead, using DOE, they completed 15 carefully designed trials, and the result was a 10-fold improvement of plant growth, and on top of that, ensuring 100% biodegradability within a period of less than 3 months. And similarly, staying in agriculture, AB Vista, they use advanced analytics to make food production more sustainable. So by compiling results from 85 different trials, they discovered patterns in animal nutrition that would have been absolutely impossible to spot with the traditional methods. And the result is much more efficient protein production with significantly less environmental impact. And these dramatic accelerations of innovation through analytics is happening across the sector. So for instance, this one is Heliatech. It's a solar film production facility, and they use real-time analytics to transform manufacturing efficiency. So their analytical dashboard doesn't only detect problems, it actually predicts problems. So this predictive capacity allows them to optimize processes in real time, resulting in significant improvement in production yield, or something that really is something that I'm often very worried about in conservation is coral reefs. So we're seeing now how analytics can help us make better decisions with limited resources. So traditional methods would assess coral reefs individually. So you would take many years of gathering all kinds of meaningful data. But with today's analytical tools, you can simultaneously evaluate across hundreds of sites, and this allows conservationists to identify and protect the most resilient reefs, creating strongholds of marine biodiversity that can help regenerate damaged ecosystems. And we really need now corals that can survive the different kind of oceans they will be living in, because the temperature is rising and all kinds of other aspects of the ocean are also changing. One last one I want to mention, a bit of a different one, but again, environmental protection, where analytics can defend nature itself. A lot of the wildfires that we see in the western United States and in British Columbia and Alberta, for instance, are actually, although climate change plays a role to make them possible, but they're actually the result of arsonists. So it's deliberately set on fire. Don't ask me why, but people do that. You want to find the people that do it. And the traditional method of finding the source of the arson was an analytics where you could discover only about 50 components. And now by the chemical compound detection capability has now been increased from 50 to about 1,000 unique signatures. So it's a bit like a DNA-like precision of solving a crime. So what connects all these stories is speed and scale. Analytics is not just helping us to find solutions, it's helping us to find them faster and to implement them much more effectively. And so in the race against climate change, this acceleration of innovation can really make a difference between crossing critical thresholds or staying within the planetary boundaries. So with that, looking back at everything that I was saying, I work with these statistics a lot. But again, when I was collecting some of these numbers, again, I was shocked at how we are ruining the only planet that we have. And so whatever, more than 300 kilograms of plastic every second into the ocean, these kind of numbers can really be overwhelming. But what pulls me back from this sense of overwhelm and what really energizes me is to see this expanding capacity that we have to solve these kind of problems. So throughout this talk, we saw how analytics enables faster, smarter, and much more effective solutions. So green chemistry, for instance, that is designing out problems even before they occur. Or real-time monitoring that can prevent waste and all kinds of inefficiencies. Or DOE that accelerates sustainable innovation, or predictive modeling that is helping us to make much better decisions with limited resources. So these data tell us two crucial things. Well, first of all, yes, we are in a crisis, and I gave you those numbers, and I can talk for hours about much more numbers that make you lose sleep tonight. But second, these numbers also show us the ability to innovate, support by analytics, and creating breakthrough after breakthrough at a really unprecedented pace. And each of you present here today have access to analytical tools that previous generations of innovators could only dream of. Tools that allow us to turn hundreds of experiments down to dozens of experiments, or to find patterns in millions of data points in seconds. Or I see Julian here explaining on how you can compare the temperature in different places on the planet to each other, how the weather is. Or you can transform good ideas into optimized solutions. Or you can scale local successes into global impact. So with that, and I don't want to overstep my time, I want to end with a story you may have heard before, the starfish story. So there's this girl walking on the beach, and she sees thousands of starfish that are there on the beach. And she starts throwing them back in the sea. And then this man passes and says, what you do is absolutely waste of your time. You'll never be able to get all these starfish back in the sea to save their lives. And then she says, well, it does make a difference to this starfish. And we are a bit like that. You may recognize this picture. This is known as the pale blue dot. So when the Voyager, which we sent out, Voyager 1, the first one that we sent away from our galaxy, when it was kind of close to leaving our galaxy, it was Carl Sagan who managed to lobby NASA into turning Voyager around. And it took one picture back before it really disappeared into space. And that's us. I mean, all of us, we live on that little pale blue dot. And we are a bit like that one starfish. So in this vast universe where we are marooned on this planet, there's nowhere else to go, and I don't want to go to Mars, and all livable planets that undoubtedly are out there are way too far away. We have to do it with these 8 billion people at this planet that you can fly around in 1 or 2 days. And that requests a lot of innovation. So with the power of analytics and sustainable innovation, as the examples that I gave, we can make a difference on this pale blue dot that we call our home. So for us and for all generations that live after us. So with that, thank you for your attention.
Thank you very much, Alex. I appreciate that. That was
Thanks, Jeff.
very inspiring. We do have time for a few questions for Alex. Excuse me. I'm going to take the moderator's privilege of asking the first one, but we have a couple of mic runners in the back. If you have a question, raise your hand and they will bring a mic to you. Alex, there's been, especially here and around the world, a lot of talk about AI, and we all know that it's incredibly energy and resource intensive, but it has the capability of increasing the speed of innovation and helping us get to solutions faster. So on average, would you say that's a net positive, a net negative at the moment, or too hard to say, or suggestions on how we might use it more effectively?
I would say it's absolutely a net positive. Of course, there's all kinds of dangers with AI, and I'm not a specialist on the dangerous side, but we should, of course, be careful that AI is not taking over our nuclear weapons or is getting all kinds of other crazy ideas. But when you talk about these kind of challenges that we are facing, you talk about such complex problems where you really need the best brains to work on it. And AI are just additional brains that we have. We talk about, let's say, we talk about the weather, for instance, weather patterns. The weather is rapidly changing. We try to understand it, but there's so many data involved, let's say, in predicting a hurricane. So if AI can help in predicting one day earlier that some kind of tropical storm will develop into a hurricane, which they do much faster the last few years, if you would have that information, you can in time warn the people to go away. You can save thousands of lives. And in all kinds of other examples, AI is definitely going to help us. And the regulations for the more scary part of AI, I leave that to other people. That's none of my business.
Other questions for Alex? No? We have one here in the middle. Where's our, there's Maria. If you would stand up, tell us your name, who you work for, and what your question is.
Hi, my name is Gabriel. I work for coffee industry, JD Peet's. My question is, in your examples, we see that people change when there is no more options. And I have a feeling that we're going to this way as well. But however, we have a lot of data, a lot of insights that they're showing us that we're going to not a so good way. So what we are missing in the message, or do you believe is also the receivers that are not paying so much attention, the decision makers that are not paying so much attention to make the change?
Yes, well, I think a lot of what is happening in the world now, in the environmental field, needs better communication. Part of that in getting the message across, it helps to work with big numbers and compile them in a way that you can tell your story. I think there's challenges for scientists, climate scientists, to convey the message. A few of them are pretty good at it and really manage to get the attention to tell their story. But I would love to see that it would be much more broadly supported by many people, that scientists and educated people that have the capability to understand the quite complex challenges that we are facing on biodiversity loss or climate change or all kinds of other changes that we are dealing with, that they do their best to communicate more. And I think there's also a challenge for the media and journalists to tell a better story of the changes that we need to make. I still see with my friends, for instance, that are whatever, they're doctors, dentists, lawyers, they're not climate specialists, how much they miss on the information that they should have. And also, so they don't understand the severity, but what they also don't know is that we have the solutions. We have all these problems that I described. We can solve it. We have the knowledge, we have the technology, we have the money. We talk about maybe 1 or 2% of GDP, which is probably less than we're now going to spend extra on defense. And with that, we can save this planet as the beautiful planet it is, with all its abundance of nature and biodiversity, and which is such a livable place. And if we don't, we make this some kind of horrible hothouse with all kinds of weather extremes, with food production challenges and water challenges that are really, really unimaginably bad for us. So there's an urgency in getting the story across. Yeah. Thank you.
Other questions? Oh, he's gonna, okay, well, let's not do that, but yeah, that's right over here.
Okay. Yes, hello, Winfried Theis. I'm going to be an independent consultant who actually wants to help with the, say, scaling up of all these great innovations that we have to actually make them work for saving the planet or kind of getting us into a more sustainable world. And one thing you were talking about, like also seeing the positive side, and I wanted to point out to a fantastic book and a fantastic source that gives me a hell of a lot of hope, and that is Not the End of the World by Hannah Ritchie from The World in Data, where she shows in many chapters, on the one hand, yes, she talks about all the things that are bad, but she also shows like how we have the chance right now to, for the first time in human history, to actually create a sustainable society. I love that book, and so yeah, it is exactly what your message is, added from a different source. And I think for all the people that are here who love data, our world in data, and this book is a recommendation that I wanted to give.
Thank you very much. It's for everybody here on your way home, remember World in Data. And when you're in the train or sitting at the airport, Google that. It's an amazing site. So talking about stories that give hope, I should have just taken all my slides from World in Data. That is just such a positive story. So in all kinds of things, so let's say if somebody tells you, there's too many people in the world, there's fast population growth, and we're never going to make it, go to World in Data, and World in Data shows you, well, actually, that is not true. Yes, Africa is still having huge population growth. The rest of the world, by about 2050, that is waning off. It's actually going down. Any kind of, let's say, environmental argument, much more than environmental, but changes in the world scale, check your data on World on Data, because they got the best graphs, they got good stories to explain it, and it is fact-checked. And yeah, her book, and what's his name? Rosling. I think she's the daughter-in-law of Rosling. Rosling has sadly passed away. But the books of Rosling, where he works with these kind of data, that's really inspiring. So World in Data, once you sit at the airport or in the train, check them, and I'm fully with you. Thanks for mentioning it.
Very good. Yes, here in the middle. Wait for my colleague to come with the microphone. Oh, it's coming here from your left. It's coming from, or your right, sorry. My left, your right. You're always right.
Thank you for the talk. Jorge Calderon. I work for Rolls-Royce, the aeroplane engine maker. Nowadays, the tariffs are very popular in the media. And sometimes I always had this question, maybe you could answer that question. Why don't we use tariffs for climate, like countries that pollute more, put tariffs on pollution instead of using tariffs for other purposes? And I always find it, especially with Europe, Netherlands, or Norway, they put a lot of effort on climate, but as you said, we all live in the same planet, so it's a bit sometimes useless to be very careful in a tiny bit of the planet where elsewhere in the planet there's a lot of pollution. Yeah. And sometimes we are contributing to that pollution with our money and our purchases, because in the world that we live in, sometimes we go to the cheaper product that is perhaps being produced polluting more. So how can we go around that? That's the question I would like to pose.
Yeah, absolutely fair point. Basically, you say, how can we better govern the planet because we make such a mess of it, right? So there's a lot of countries, let's say in Northwestern Europe, including my own country, where we claim all kinds of environmental successes for the very simple reason that we just send all the pollution to somewhere, let's say in East Asia, where they now create the same polluting product and we import it, and our pollution has gone down. Yeah, but your question was, how do we solve it? I've been a diplomat for 25 years, and I can tell you from my experience, it is horribly difficult to find consensus between 200 countries in the world on dealing with environmental problems. But as I said somewhere earlier in my talk, where I said about it's just so difficult to find an agreement how it is fair, what to share in the world, etc. I mentioned you more than 4 million people are in the state of hunger in weeks from now. They need more than $1 billion for that. They have only 12% of the money to take care of it. This isn't even in the newspapers. absolutely unfair. Our planet shouldn't be like that. A planet that is so connected, where you can, in 4 hours flying, you're in the middle of the situation where I'm talking about. And there's just so much is unfair on this planet. And I've been on the side of trying to find multilateral solutions. And of course, as one man, you can just work on specific issues. With multilateral agreements, we can make progress. So let's say with climate change, I'm happy that at least we set a limit to how far we can go. But then, of course, the next question is, how do you get there? So there's a lot of negotiations going on. But ultimately, it's extremely difficult to make the progress. There's also positive examples. So for instance, I've worked 6 years of my career on nothing else than landmines, getting landmines out of the world. There was, after all kinds of conflicts, the conflicts had ended, but the weapons kept fighting. The landmines were still in the ground, blowing up women, children, men that were working there, with horribly maiming them. And it was, it seemed impossible to stop until NGOs started to unite and to work about this and start a worldwide campaign to stop producing landmines, to use landmines, that we should be by law required, by international law required to clean them up, by no longer trading in landmines, and all these kind of limitations to solve the problem of landmines. And it resulted in 1997 in the agreement, the Ottawa Convention. And since then, the number of victims of landmines has dramatically gone down. So that is an example where just one NGO, Handicap International, finding a few other NGOs to start a lobby, and ultimately more than 1,000 NGOs united in one big campaign. Then they got a few countries on board, Canada first and foremost, Netherlands was one of the early ones, and ultimately resulting in thousands of lives not lost. So there are positive examples, but yes, I'm with you. I mean, there's so many things we should do better. That's, I don't have the solution there. Yeah, keep fighting for it, keep pushing, help NGOs, support the countries that do their best.
I want to thank you very much. It was indeed inspiring, and I think you've given us all a lot to think about. I do appreciate it.
Thanks so much, Jeff.
Thank you. One more time.